Hi everyone, I'm Aaron and this is the video for dynamic analysis for my MATT final assignment. So, before we get started, a brief overview of this malware executable that I'm going to be conducting malware analysis on is actually this automated malware here. And if we search up the malware that we're conducting, which in this case is the MD5 hash of this value, if we search it up, we can actually find this sandbox cloud analysis report here, and this allows us to get a brief idea of what malware we're actually dealing with. So as you can see, this malware has many different classifications. Mainly it is identified as a Trojan, or it is identified as a evader. So in this case, an evader is a malware that could be hard for us to detect because it obfuscates its own behavior, and it might be self-aware, which today we're going to find out if that's the case. So in this Windows XP victim machine here, we have actually already imported the zip file that we have acquired from VirusShare. So this is the zip file for VirusShare that has the malware already inside. So we're going to extract the file really quick. And as you can see here, the file actually contains a normal document, which in this case, we're just going to rename this into an exe executable. And now you can see if it shows this icon, then it's most probably a application. So before we get started, there's a few things that we need to make sure we have open. So first thing would be Process Explorer, and this actually shows us what processes are currently running. And then we will need this opaque DNS that will show us that if there's any new domain requested. This is particularly important because it shows us any network indicators that the malware is actually currently executing. And then we will also need reg short, which is the registry short. We're also going to be using process monitor, but in this case we won't want to open it right now. Well, we can, but it's very long, so we're just gonna leave it open, but we'll get to it later. Okay, before we get started, we need to make sure that our computer has the correct IP address. As you can see, this is the IP address that we assigned, and which is what we configured in the document, in the report. This is the IP address that we are going to be using today. So with that in mind, let's make sure that our computer has the correct internet adapter settings. Let's just change this into 127. Setting it like this will allow us to detect if there's any DNS request on our opaque DNS. So just to check again, yep, set already. Okay, right here we need to set it to, and then we'll start the server. Okay, so before we start running the malware, we're going to first take a registry shot. And we have to make sure that it is clean so that we can filter out any new Windows registry changes before the malware is even run. So let's take a second shot now. As you can see, there's already a few changes in the values. So what we're going to do is just clear it again. I'm going to take a shot, the first shot again. We want to make sure that this is done a few times so that we don't get messed up with what the malware is actually changing. Okay, comparing now, there's now a kind of clean system here. We're going to just clear it and do it one more time just to be safe, because we want to really record down what exactly the malware does, and we want to see if we can find anything from when we execute the malware. Let's take our second shot. If this second shot is clean, we can always use the first shot as reference, and we can compare it throughout the duration where we run the malware. Okay, so now there's a remote access point error. We're just going to ignore this so far. Let's clear the second shot. So now when we want to run the malware, there's a few things we need to take note of. We're going to look at it on the Process Explorer here, and we're going to see if it generates its PID, which is its process ID, and how much bytes it actually takes. So when we run the malware, let's run again. It's not showing up currently. Try running it again. Now it runs. So as you can see, it ran right there and then it disappeared immediately. So let's try to take our second shot first, immediately right after we execute the malware, because we want to see what registry changes it makes. So now when it's done, let's compare. So you can see that there's more values added. Previously it was just these remote access keys that were modified, but now as you can see that there are values added. And in this case, you can see that in the HKU directory, there's actually some software changes, and the shell script is some shell scripts activated by the exe here. That's about the current changes, and you can see there's values modified here in the HKLM2 and the HKU directory here too. Current version Explorer. It could mean that the malware is actually making changes to the software. As you can see in the current version, with a weird directory here, and this directory looks kind of obfuscated with this dump of a string here, especially this whole entire directory here. So it could be the malware making something that is trying to hide in, or is trying to cover its existence. So now we're going to just close it, and we're just going to clear the second shot. Right now we're going to run the malware again, and we're going to try to catch it on the Process Explorer and view actually its properties. So now if you quickly click and run properties, you can see that we didn't get it. Okay, let me run it again. We managed to get it here. As you can see here, the parent is actually from Explorer exe 1696. And let's take a look at its strings. So as you can see here, very evidently there's DLLs being found in the strings property, and these DLL could mean malicious directories being imported. And if you can see here, it says that the application has made an attempt to load some library incorrectly. You can see that there's unable to initialize certain things, heap. So it also has requested runtime to terminate it in an unusual way. So this could be a indicator. Runtime library. There's a lot of runtime errors, and this is like the program script with it. Now let's just look down and let's just look at the strings, and maybe we can identify something that could be useful to us. As you can see here, there is a directory that is found in the strings properties. So this could be something useful for us. This could be a host-based indicator where the malware is trying to hide in, but we're not sure of that. Maybe it's just accessing it or something. So we'll continue to look down. So far it looks like just packed, like the malware is packed. That's why it comes up with all these strings. But if we just use a scroll feature really quick, you can see that it runs all the way down until this last part here. Let's see if there's anything. It's looking at variable file info. Let's just look at this here. So this is a very important bit of strings here. So suddenly we can see that there's get computer name, find resource. There is also create hard links. There is load library. Let's see if we can find any changing settings, strings, extract associated. There's a lot of different DLLs here, and there's a Windows HTTP DLL actually imported. This is pretty big. If I can recall correctly, in our static analysis, there is actually a DLL that's imported that is related to this. Windows HTTP DLL, as you can see here, is one of the DLL library that was imported when we used static analysis on it. So there's a very big sign here. Let's just look. Look, there's a terminate process string here. This is a very big indicator. This create file A here is another big indicator. Now we're just trying to look for any network-based indicators where it connects to any domains, because in the basic static analysis we did identify a domain. If I can reference it here. Let me see. Remember there's a domain that we managed to find. Yeah, there's a HTTP, Windows HTTP DLL, which we saw. Get computer name A. Basically, what we have identified in the static analysis, we can find here, because it's around the same strings. There should be the same strings. But using Process Explorer, I want to showcase that we actually can find these strings too. Okay, so let's move on from this part. If we were to look at the Process Explorer again for a moment, you can see that it terminated in its own self, right? So how are we able to find something in the process monitor to reflect any suspicious activities from the malware? So let's just filter it by create file here. Let's just include this, okay? Process name. So if we filter it by the process name, we can actually find out and dive deeper if there's any executables that are doing the same process, the same operation. Yep, let's look at that. Look, it's all these create files. As you can see now, it's a lot of the process explorer conducting these operations. Actually from all of them. Let's look at create file. Let's include create file. If you filter it just by create files, I want to see what we can get. So for the rack shot again, we're going to take a second shot because maybe after a certain period of time, the malware might come out and review itself. As you can see here, previously we take a look at this brief report. If we click on this, the may sleep evasive loop to hinder dynamic analysis, we can see that there's actually a thread sleep time here for the malware. So it contains long sleeps, 3 minutes, to try to hide itself. So we want to just now this is important too because the process monitor has suddenly stopped. This could be an overload of resource from the malware, or it just could be a normal overload of process monitor. So we're just gonna restart this if we can. Okay, it just stopped. So let's run it again, just to make sure that we can find something, hopefully. Look at this create file and include create file. Okay, so now you can see these are filtered by create file. We'll take a look of that later. We're just going to take a second shot. We took a second shot, now we're going to compare it. If you can find anything new here, it will be good. So these two values are the same values that we found previously. And then these are just system changes. These were the ones that could be from the malware. Just a disclaimer. Previously, when I conducted dynamic analysis, these might not be the strings that I find, but particularly this one isn't. I didn't find this registry change, but I did find this one. But what we're doing now is around the same thing as when I first conducted the dynamic analysis. So let's close that and let's clear the second shot again. I'm just going to take one more time, take a second shot one more time later to see if there's any more changes. So now if we take a look at this, we just need to look at these create files and try to find if there is any familiar DLLs that we can spot. So this would be important as we can maybe point out what the malware is actually doing. Look, if you just go down, just a quick scan if the malware is doing anything. It could be from any of these processes because this malware actually kills itself or changes its header, so we can't actually spot it really clearly as it doesn't have its own process. So just a brief run through if you can see anything. Doesn't seem like we can find anything. These DRLs seem to be the same. We can't really take this kernel 32 DRL as a malicious one because it is already on the regular Windows system. Just gonna run through this to see if there's any Windows HTTP DRLs. Doesn't seem like it. So from process monitor, we can't really spot anything, and that's okay because this malware could be self-aware that it's inside a VM, a virtual environment based on this indicators like VM2's exe. These indicators could mean that it's in a sandbox. Now, if you look at the paid DNS, we can identify it as there's actually a WPAD um, domain request here, and WPAD is actually a web proxy. It's actually a web proxy. Yeah, it stands for Web Proxy Auto Discovery, which is used by clients to actually uh, get configurations from through DNS requests or DHCP requests. So this could be a way for the malware to set up traffic interceptions, or to start up any man-in-the-middle attacks, or just to recon this machine. I can't really classify this as a network-based indicator, as it doesn't clearly show the the malware requesting to an outside network or to an outside domain. So this is just very speculative. So lastly, we're just going to take one more registry shot just to see if there's any changes to the registry. As you can see here, suddenly there's more service added here. Could mean something from these additions. Now just look around at the other registry keys changes. So clearly these are the four that are added. These keys are added. This could mean something, but it could also mean it could also come from the process monitor shutdown earlier, which might trigger this. So this could be a normal Windows system registry key change. But it could also mean that the malware is actually tampering with the registry keys. As you can see here, it goes to some root directory, and it has this control directory here. So this could mean something, that the malware is actually enabling remote access, or to actually privilege escalate itself on this client machine. Yeah, so that's about it for my dynamic analysis part. We didn't really identify a lot of indicators of this malware. Particularly, it's very good at hiding itself from our process monitoring, our process analysis. It doesn't really show up on the usual dynamic analysis tools, and when there is certain indicators that could mean something, it's mostly really speculative, and it's hard to filter through and identify which ones are really caused by the malware. So we need to keep a longer eye on this malware, and if it changes anything with the registry. But I doubt that it will show any more signs, as it did a really good job hiding itself already.